Hello, everyone. Sorry for being a little bit late. We had a couple of issues. So good morning, good afternoon, or good evening, wherever you are. And welcome actually to the sixth Journal Club session on cardiac imaging. First of all, I'd like to remind you that this session is being recorded and will be then available probably early next week on the Lyric educational website. I will share you the link during the session. And I actually see that we have a lot of people today, a lot of new faces in the call. So welcome to all of you to this journal club. I'm Aurélien Bustin. I'm a researcher at the Lyric Institute in Bordeaux and at the CHUV in Lausanne as well. And I'll be moderating this session today. So as you see on the flyer, we have a very special journal club today on the topic of image reconstruction. That's a topic I particularly enjoy. And why did we organize this session? Because like most of us, I faced at some point the difficulty of integrating my reconstruction tools, my developments into clinical practice, right? But we do have tools out there that could help us reach that goal. And so I'm very pleased to welcome two experts today who are going to guide us and highlight us on these two frameworks. So on the one hand, we will have Valérie Ozen. Valérie will share his expertise with Gadgetron. So Valérie is a researcher at the Lyric Institute. And for those of you who have already used Gadgetron, actually, you probably already interacted with Valérie because he is the one, always helping and answering questions on the Gadgetron website. And on the other hand, we will have Davide Piccini from Siemens, and Davide will talk about the recent Fire whip that basically allows us to push our recon codes on the Siemens scanners. So guys, Valérie and Davide, thanks so much for joining the Journal Club, for sharing with us your expertise. I'm sure we will have many questions for you about the differences between these two tools, what are their advantages, disadvantages, but without further ado, let's start with our first speaker, Valérie. The room is yours. Thank you very much.
Thanks, Aurélien, for the introduction. I will share my screen. So to start this presentation, I will begin not by the Gadgetron, but by something associated with it. It's called ASMR-MRD, or magnetic resonance raw data. So basically, I will start this presentation by speaking about the motivation behind the Gadgetron. And MRI is a modality that give us the possibility to have qualitative information, but also quantitative information, like biomarkers. So you can do tissue characterization, you can monitoring respond to treatment, or you can do also some predictive parameters after a treatment. And the idea behind is based on a typical sequence, whatever it is. So I pick the example of MP2H. You can get the T1 value. And the ultimate goal would be based on the T1 value to make a differentiation between a treatment A and a treatment B. So for doing that, you need the multi-center studies, and you have lots of variability. So the variability in what we are doing is at different scale. It's we have different MRI vendor, so with different hardware for the channel, for the gradient. We have different sequence. The implementation differ a bit between the vendor, and you have also the reconstruction process, which is in general a black box. And then we have a norm called the DICOM that allow a uniformization of the image after the reconstruction. And if in let's say in neurology, there is a big organization for like the Connectome project, where they make some harmonization of the process in order to make the data more valuable. And the idea, so it was mostly 10 years ago, was to create a new norm. Instead of using the DICOM for the image, a group of researchers introduced a new format for CASPACE called the MRD CASPACE. And the idea was to get the same structure and to have an harmonization of the CASPACE data in order to improve the reproducibility. And now there are lots of paper in the community to improve the reproducibility for the T1 mapping or T2 mapping. This is something that we're going to do a lot in the future. So this was the initial motivation. So the design, let's say, a structure that can handle the CASPACE. So you have the readout data with magnitude and phase, but you can also integrate physiological information, data from the scanner, and also segmentation like contour. And the idea behind was to, if you scan, typically it was the initial publication, if you scan a kiwi from different MRI, you can apply the exact same reconstruction code, whatever the language you use. So it was designed at first in MATLAB, Python, and C++, and you have a piece of code that can convert the raw data of each vendor to the common CASPACE raw data format. And people are now using it a bit, but not a lot. But recently, for instance, Facebook organized a big challenge for reconstruction, and they use as a starting point the MRD format. So it's a way to see the CASPACE data, and for Siemens user, it's not so far. It's not really different from the map VBVD file. So it's not a big deal to switch from the Siemens standard to the MRD format. So this is the ISM-MRD format is a project. It's associated with the Gadgetron, but it's a bit different. Okay, so now I will introduce a bit what is a Gadgetron, and but I think there will be a bit of similarity with the next talk, so I'm gonna go fast on that. But basically, the idea was to improve the flexibility when you want to integrate your code for clinical research. So this is a typical reconstruction. So you have the scanner, the host where you launch the sequence, and you have a server behind called the Mars, which does the reconstruction. And if you want to use typical implementation like Python or MATLAB code, or if you want to have a specific GPU card using your clinical scalar, it was impossible to do the reconstruction in clinics. So in 2010, Michael Hansen and his team, they create the Gadgetron. So it's a client that will hijack the Siemens reconstruction. So basically, it's working this way. So when you launch the reconstruction, the CASPACE are sent to the Mars, and you have a list of box called functor that will process the CASPACE. So a functor can be a simple FFT, or it can be a compressed sensing algorithm, but it's a black box that is designed by Siemens or by researcher, and then let's say marked by Siemens. And the idea was to create to add a Gadgetron emitter that sends the CASPACE to another computer that will do the processing, and then you send back the result to the MRI. And it's completely transparent. and you can put in your gadget the best hardware and the best software or libraries you want to use. So feel free to also, sorry to interrupt me if you want to, and if you want any detail during the presentation. So this is some slide from Ruixu working at the NEH. So he's running, for instance, some perfusion, cardiac perfusion, and there is and he was presenting 3 setup. So you can either put the gadgetron on the Mars. So I mean, you just you have an image of the gadgetron and you put it on the system of Siemens. You can also put the gadgetron on an external computer, or you can put the gadgetron on the cloud anywhere in the world. And you have a connection, a network connection that are transferring the data automatically. So in this case, I will redo the video. You should see image coming back to the scanner. Then you can see a color map image. So you can, and also some plot. You can also send back plot to the MRI. In that way, this information can be used directly by the radiologist, the physician, during the patient examination. One original motivation was to improve the computing capabilities during the reconstruction process. So in this example, they are doing cine images with in-free briefing, and they use compressed sensing. So without compressed sensing, you have a bit of noise, and then with compressed sensing, you can really remove the noise. And the reconstruction is it's a 2D multi-slice acquisition, so you can run each reconstruction independently by slice. And they design a cloud reconstruction where you will have a balancer that will create different nodes of the gadgetron, and then each node will do the reconstruction of each slice. And using this kind of system, you can decrease significantly the computing time to less than 1 minute in this case. And it was therefore compatible for clinical workflow. So you can set up this on a commercial cloud, but you can also set up it in your lab if with different computer of PhD student of, or if you have a big computer in the lab, it's possible also to set up. So this is the main functionality. So it was to offer a large flexibility in hardware, but also in software. I would like to highlight that there is no specific area for gadgetron. So there is a community. So this is some abstract or article related to the gadgetron. So there's a big community in PET-MR that are using the gadgetron. There's also a big community in cardiac reconstruction, in particular at the NIH for compressed sensing reconstruction, especially in the cloud. You can see people are really interested also for model-based reconstruction or fingerprint printing when you need dictionary. So you can use it and put it on the clinical scanner. There are also people doing real-time feedback MRI with Bold in London. If you want to connect your scanner and send the image to for doing augmented reality, you can do that. And there is finally my, let's say, area of expertise. Lots of people working in interventional MRI because it gives us lots of flexibility for real-time processing. And you have also people working in low field. So and there is more. But in case if you want to have the connection with this group and people, and you're interested with typically a bit of expertise on these topics, I can give you the email or the contact if you want to have some information how to use the gadgetron in this area. There's also some spectroscopy. So now I'm gonna spend some time to show you a bit some example. So it's mostly related to what I've been involved, but it's not limited to. So I think the most interesting things is to use MATLAB, because personally I use it a lot, and you can put your MATLAB code in a MATLAB gadget, copy and paste, and you have to trick a bit, few things, but it's working like a charm. So for example, so I will show an example made by Aurélien Trottier at Bordeaux. So this is a MP2H sequence with component sensing. So we have, I think, a Poisson disk acceleration in the YZ direction. So it's a 3D acquisition. And we are acquiring two echo 1, echo 2. And from the two echo, we can reconstruct an MP2H image. So basically, we copy and paste the MATLAB code that do the reconstruction in a MATLAB gadget, and we call BART. So BART is doing the reconstruction, and what BART has done the reconstruction, we send back the image to the scanner. So you can see on the right, this is the screen of another computer, and on the on this part, you can see the activity of the CPU. So at the bottom level, you can see the network activity. So after acquisition of each I can say not echo, but succession of echo, you can see a bump of network activity, and then the second finished and the network stop. And then the reconstruction will start. I'll go a bit faster. Oh, sorry. And okay, and when it's done, the image are sent back on the scanner. So here you can see it. And finally, you can go to you can go to the folder and see the different echo and look at it with the Siemens tool. So in practice, it's super magic, because you take your MATLAB code, you copy and paste, and then you send back the image. And this is the code. So I think it has been released previously, but you have to put your BART code. And then the only thing to be sure is to scale the resulting image as a DICOM format. I mean, in unsigned int. So the data has to be scaled between 0 and 4096. That's the only part. And so it's helping a lot if you want to test on the volunteer sequence, because you don't have to anymore copy and paste the data from a computer to another one. You get directly the result. So it's faster, the development. The other super interesting things is to combine the sequence, or also with tricks, it's working, plus breakpoint. I mean, you can launch the sequence, you add a breakpoint in VS Code or in MATLAB, and then you call stop. And then if you run it, it's doing the reconstruction and sending the image to the scanner, and you can debug your code like that. So for the final integration. So breakpoints plus tweaks, or breakpoints plus the launch of the sequence is really, really useful in practice. So in a way, for instance, if you don't have a practical cases could be, you have a sequence and you haven't done the reconstruction, so you can run it on the Siemens, and you can remove in IDEA command tools the ICE reconstruction, and so you get the tricks data saved, and then with tricks you can call the ICE Gadgetron functor to send the data to Gadgetron, and then you can play with it and send it back to the scanner. I will talk a bit about sparsity. So one huge limitation of the Gadgetron is the documentation. We try to improve a bit. So now we have a new form. And, so it's called Gadgetron Discourse. So basically there is every week a hangout with people from US and Europe. We are a small community of, let's say, 10 person. There is a new wiki page with the doc. And there is some material on the web by different group, but I would recommend also we organize a summer school in 2020, and there is the video on YouTube, and there are also the material on GitHub, and there's a lot of information in the YouTube page and in the video. So don't hesitate to look at it if you want. And also, I think also to connect with people during the Hangout. Each of us have a specific area of expertise, and we can help you for the starting part. What time is it?
23. You still have a couple of minutes.
Okay. So I will present briefly some slide about real-time MRI. So the Gadgetron is well designed for real-time MRI because in this context, you really need the most appropriate language, computing language, but also library to deal with your scientific topics. So in this case, the subject is in the MRI. And when you run the acquisition, so you will reconstruct the image as fast as possible. But you may also need to add additional information or additional processing like motion correction or any additional computation. And you may interact with a medical device in order to monitor the physiological response. So this kind of situation is, so the most standard case is neurofeedback in functional MRI, but also there is another case with temperature mapping. So where you want to monitor the temperature relation during a thermoablation with a medical device. So this is an eye fluting on a piece of gel. So in this case, I may skip some slide to go faster. I will present two scenarios. So related to the work at LYRIC, where we do radiofrequency ablation in the heart, and there is the interventional step where we do radiofrequency ablation in the ventricle. And basically, I made another example where we are running the acquisition with an API sequence. We are sending the task space to another computer. The computer is reconstructing the magnitude and phase image that are sending back to the MRI. And we also deal with the respiratory and cardiac motion with a nonlinear motion correction. So we use CUDA code. So it's using the graphical unit of the computer. And we then, with the Gadgetron, it's like the masterpiece of the reconstruction, because it's also connecting with the MRI, but it can send also information to other visualization software to display the temperature, but or any other image. So, and in that case, you can integrate a lot of things. So you have to do so in that case with the API, and with there is also SMS reconstruction in that case. So you can do the API correction, the call compression, the slice graph reconstruction, and the graph reconstruction and you can send back the image to the MRI. But you can also add at this location any other processing that will apply on the images, like motion correction or statistical analysis of the result. And you can send back the image of the statistical analysis to the MRI, for instance. The second part, I will go briefly on that, because Davide will speak also about that, is we can use it for evaluation or yeah. So for instance, in this situation, we perform some ablation in the ventricle, and and you can see, so this is T1 recovery sequence with contrast agent and without contrast agent, and you can see here or here a big lesion in the ventricle. There is many here and here, here and here. And the idea was to quantify the size of the lesion and to send back the information to the clinician as fast as possible. And in order to do that, I did something, in fact, it was quite simple. I use a CNN network to segment the ventricle, so using the endocardium, and to get the endocardium mask and the epicardium mask. And the idea was behind to compute the wall thickness and to extract the lesion transmurality. And basically, so I have a gadget that gets the pair space, the second gadget that uses bar for doing the reconstruction, the third gadget that called Keras and does the extraction of the mask, and another gadget that is sending back the image and the segmentation to a visualization software. So, and just at the end of the sequence, you can see the lesion in a 3D, in a volume rendering window, and you can see the extent of the lesion. So it's an example, but it's a way you can use the Gadgetron to faster the information you get from the MRI, but also to improve both the display and the way you present it. I will skip it because Davide will talk about it, but basically we have MATLAB gadget, but you have also Python gadget, so you can copy and paste any Python code. So it's super useful because now there's a lot of library in image processing that are coded in Python. So last thing is, if you're interested with this functionality, you can even send back the contour on the host. So there is a way to do the segmentation and to segment and to send back the contour, or to send back a line or dot on the interface of Siemens. So if you have quantitative information and you want to plot it on the host, it's possible. So, and this segmentation, for instance, was made by the group of Peter Kellman and with Rick Su, and they put the Gadgetron on a typical amount of scanner in US, and they were able to do a study with 15,000 patients in few days. And in their paper, they can say that the model was loading quite fastly, and it was super successful. They have one fail out case. So you can really take your, let's say, dictionary or model, put it in the Gadgetron, and go to and test it in real life. So, it was let's say a large overview of some, and I prefer to present some application. I don't want to go into detail, but there is a lot of computing in the Gadgetron, and this is, let's say, the bottom point, because at first glance, it's quite complicated. And it's true. You need a bit to know as a few things in C++ or in Python, MATLAB, Docker, in Unix, in network also. You need also have some prerequisite in reconstruction in MRI, but that's okay. And you need also to understand how the sequence are set and how the data are organized when you are generating the car space. And you need also, because I think most of us in France and in Switzerland are working with Siemens, I think so, in this call, you need also to understand also the Siemens logic. But so this is a bit difficult at the beginning, and so don't hesitate to ask help at any moment if you want to start with. But I think so. I was highlighting that now the Gadgetron is working in Bordeaux, in Marseille, in Nancy, Paris, Lyon, Strasbourg. So I think most of the research site in France have adopted the Gadgetron, and I will be curious to have some feedback if you wish during the end of the call. And the most interesting part is, I think it's open source, so you can really look at the code, understand everything if you want. There is no limitation. There is absolutely no limitation of what you want to do. As the code is open, as you can put now MATLAB, Python, Julia, C++ code, and you can have all of these gadgets separately in the same reconstruction process. So you can take whatever you find in GitHub on the internet and put it and use it in a real-time reconstruction at the scanner. And I think that will be all for me.
That was really nice. Thanks so much, Valerie. And I like your last slide. We'll keep the question for the very end of the session, if you don't mind, sure. With Davide. But before I introduce Davide, are you guys planning a new summer school workshop on Gadgetron, Valerie? Or?
Yes, that's something we are thinking about. Okay. Not this year, but maybe next year. I think this year will be a bit complicated. COVID is not completely end, and situation in Europe is not fantastic. So I think we're gonna wait for 1 year more.
Okay, then wait a couple of minutes, and I'm sure if a lot of people are gonna have a lot of questions for you at the very end. So Davide, I think it's your turn. Davide Piccini is a Siemens employee. He's gonna talk about the Fire Whip, and Davide is also working with the team of Professor Matthias Stuber in Lausanne, for those of you who don't know Davide. Davide, the room is yours. Thanks for joining the call.
Can you hear me?
Yes.
So thanks, Aurélien, for the introduction. And I have to really thank Valerie for his presentation, because he made my job much easier, I would say. Because one of the motivations of FIRE is historically actually to maintain Gadgetron. Because as Valerie pointed out, Gadgetron was developed at NIH by Michael Hansen, but together with indeed Hui Xue and Peter Kellman. And there were several applications that they implemented and they wanted to distribute with Gadgetron. And Siemens had historically to maintain an interface to Gadgetron so that they didn't have to do it every time. And at some point, Kelvin Cho arrived. So working with Peter Kellman and together with the headquarters of Siemens, decided to do this in a more generic way. So they came up with FIRE, he specifically. And I'll try to explain. I never used Gadgetron, I have to say, so I cannot probably point out exactly the differences, but I'm gonna try to lay out how FIRE works. And as a disclaimer, these slides, as well as all the work on FIRE, are basically to be attributed to Kelvin. So I don't take any credit for what you will see. But if you have any questions, I will try to answer, because I'm supporting this project since the beginning with him. So as Valerie also pointed out, there is a need for a faster translational prototyping. So many groups, what they do is they have their own reconstruction or even post-processing tool that they have in their computer, in the PhD student MATLAB, or maybe in a server. They extract some raw data at the scanner, usually 10 to 11, and then they publish a paper. But this is, while this is very interesting, and maybe they wait for somebody to pick it up that has capabilities of putting stuff at the scanner, this doesn't scale well. So the idea of FHIR isn't it to streamline this post-processing and this reconstruction and try to make it as easy as possible for research groups to bring their prototypes to the scanner. And to the scanner, I mean directly to the Mars. So FHIR allows you to connect an external computer, an external server. However, the main scope would be to run your reconstruction at the Mars, so at the reconstruction machine of Siemens. So the idea is very similar to Gadgetron. It's an open interface and flexible. It's actually distributed as a Siemens WIP. So the WIP exists over, I think, all the released baselines from V11C2 and NX VA40 even. And you can have an online and an offline version. So one that you install at the scanner to run your prototypes at the scanner, and one that you install locally in your IDEA environment so that you can prototype and debug your code. So basically the idea is that you have your own indeed reconstruction or post-processing pipeline in MATLAB, Python, as you will, your network trained with a lot of data you have in your hospital, and then you can deploy it at the scanner and run it there. And as Valerie pointed out at the beginning, this is great for sharing your work. So to go multicentric. So not only to extend your study from 10, 11 volunteers, but to X patients that you might run in your institution, to even multicentric studies. Because if you think about it, it's with Gadgetron, you can do it anyway, but with FHIR, that would be a Siemens WIP that any institution can obtain with a very small contract with Siemens. And then you can distribute your application with a C2P, if you're familiar with it, which is just like one small paper to sign between two institutions so that you can deliver your code at the scanner. This is a figure that is very similar to what Valerie showed, but it's with FHIR. So FHIR is indeed just a protocol, basically, that interfaces you with the ice reconstruction. I have no idea if you see my pointer. Okay, I do see it now myself. So it's basically how it works is that at the scanner you add an ice program on top of the ice program that is run with the sequence that is at the scanner, that puts an emitter and an injector in your pipeline. The emitter has a converter from, and thank Valerie again that because he explained what ISMRM-RD is, converts your raw data to ISMRM-RD format, and then sends it out to your FHIR application. And then an injector where you can inject your result, being it images or post-processed images or contours or color maps or what you will. And this supports fully Gadgetron, so they are not mutually incompatible. It's actually quite straightforward, according to Kelvin at least, to have your Gadgetron gadgets implemented in FHIR. It supports MATLAB, Python, BART, Yara, and what you will. I actually saw several examples in the last months in which, for instance, there was a BART framework-based FHIR application, a couple of MATLAB, a couple of Python examples. So this is actually growing quite fast. So here it's very similar to Gadgetron. The protocol goes with the ISMRM-RD format, and it's basically a client-server communication. And you can find all the information about the ISMRM-RD in a Git repository, actually, which you find here. And there is indeed also the Gadgetron ISMRM-RD. So this is an example that Kelvin showed quite often that you can do at the scanner. So with Python, for instance, the good thing is that you don't have to compile the code. So you can even copy your code directly at the scanner. And then this allows you to actually change what you're doing on the fly. So for instance, here you run a mini flash sequence on a Phantom. You have your Phantom. Then this is the script that does the reconstruction for Gadgetron, for Fire. And then you decide, for instance, you want to invert the contrast. You just add the 3 lines in Python, 2 actually. You just do, an image inversion, then save, close, scan again. It will call the same Fire application, so the same Python file, and you will get at the scanner your inverted image right away. So if you are prototyping in Python, you can actually do stuff at the scanner. MATLAB is a bit more complicated because you cannot install MATLAB licenses at the scanner. That's a limitation. So this is an example that was recently published. So Princeton came up with a cardiac CNS segmentation using PyTorch. And this is one of the main drivers of stuff like Gadgetron or Fire, so that you can put your neural networks, you package them in some sort of container, and then you call them from the scanner. And basically, here you just see how the data is rearranged in a NumPy format here, and then here given to the Python network. So it's really like simple snippets of code that are provided also with Fire as an example. And as I said, you can run it offline or inline. So this is, I don't know, probably most of you are familiar with it. This is the Siemens offline reconstruction environment. So here you have IDEA, where you call ICIMU. Here is the simulation window, and here is the Fire client window. So you can see that if it starts, yes, you can see that the data is now sent to the Fire server. And here is the ICE reconstruction that is working in the background, because Fire is not exclusive with ICE. So ICE can work in parallel with Fire. So you can have 2 reconstructions at the same time. Obviously, you have also the option to have one only. And here you see that the data gets reconstructed also by Fire and is calling the neural network for the segmentation. And you can offline with this, the usual Siemens tool, you can assess the reconstruction of the ICE pipeline and the result of the neural network. Same thing at the scanner. So what you do basically is you package your code into a change root or a Docker, and you deploy it at the scanner, and then it works exactly the same. You run your acquisition here, and then when the reconstruction starts, it will call in the background your change root, and here you get at the scanner the Cine image by here ICE, and here the segmentation performed by the PyTorch network. So this doesn't work only with Python. As I said, it works with all sorts of languages, C++, MATLAB, Python. And since most of us use actually MATLAB for prototyping, there is online, Kelvin provides both a Python example and a MATLAB example. And the MATLAB example is very similar. The reading of the ISMRD raw data that come in for Fire is very similar to the MapVBVD. So the interface you get for MATLAB is pretty much as if you loaded the Siemens raw data with MapVBVD. You do the same in Fire. You load the ISMRD format now into a MapVBVD, and you get the same format you are used to in MATLAB, and you can prototype. So I'm not sure how Gadgetron deploys MATLAB reconstructions, but of course, as I said, at the scanner, there is no possibility of installing MATLAB or installing licenses of MATLAB. So what you have to do here is to compile your MATLAB code and encapsulate it into a Docker or a change root that you can deploy at the scanner. In this case, you don't need a license, and you can run the code at the scanner. So this is not as easy as debugging it offline. Of course, you could connect your external computer to the scanner, and then you could debug offline, but it's not always possible. Like, not all the hospitals have these capabilities. Imagine if you want to do a multicentric study, you cannot like pick the hospitals that have IT or IT people that can connect an external computer at the scanner and maintain it. What you would like to do is hopefully package your reconstruction into something that can be loaded in the Mars. So basically, you just deliver to this institution the FireWhip, your reconstruction or post-processing, because the emitter and the injectors are very flexible. You can place them anywhere in the reconstruction pipeline. Even at the very end, when the image is reconstructed, if it's just a segmentation, you send directly the DICOM images, convert it to ISAM MRD, and you send back your post-processing. And this basically, in theory, makes it very easy for deployment. And this is exactly why this is now starting to get in the form of a community. We have we don't have a common page. Kelvin is maintaining examples in Python and MATLAB online that you can freely access. However, we have a weekly call that I am sort of administrating. So who is interested can come, and then Kelvin basically reserves from half an hour to 1 hour every week to answer questions. You can share your screen with the bug together. People can join, and if they're interested in the topic, they can stay. If they're not interested, they can leave. It's actually very dynamic. I think in average now on the call, there are 15 people or so. And basically the only thing you have to do, if you have obviously a Siemens scanner, is to work with Fire, is to ask for the FireWhip, and then to contact either me or Kelvin. I'm more like the contact person for Europe. Kelvin is for the US. And then we try to set up a project with you and include you in the call. And as I said here, the sharing is WIP plus C2P agreement. And indeed, okay, this is the Kelvin's email. I guess he gets about 100,000 emails about Fire every week. So maybe try not to write to him directly. But if you're interested in starting with this framework, you feel free to contact me.
Thank you very much, Davide. Thanks so much. The room is open for question now. Valerie, are you still around? Yes.
Yes.
Any questions for Valerie and Davide Piccini? Someone in the call?
I have a question. Can you hear me?
Yes, Karina.
Hello. I have a question for Davide. How do you run the file in the simulation mode? Because we have a problem with the license, and are there any tricks, or we have to ask for a separate license for a standalone computer?
I don't think you need a license to run Fire in the IDEA environment.
Maybe I configured the XML, how you say?
Yeah, maybe it's an X. So one problem that I don't know when you got the FireWhip to try, but one problem that is a very stupid one that Kelvin is facing because it's his fault. No, it's that when he released the whip, he had to put a number in all the files, and then sometimes the XML is just calling the old name of the file. And I don't know, this question came up, I think, 5 times in the last calls. I don't know if it's your problem, but if you want, I can.
What I was doing, I was just copying the raw data from the Siemens scanner, and then run the simulation as usually. And then even after the copy of the XML files, we had an error, which was talking about the license, etc. So we had to change the UI config in the OVP file, or it was in the other format, I don't remember, and go back to the Gadgetron.
I mean, if I can, I don't know exactly what the error is, but if you want, I invite you in the next call, and then we can look together with Kelvin. That's exactly what we do. Like, you show the what happens in your environment, and then we usually figure out a solution 95% of the cases.
Okay, so how I can connect to your meeting?
I'll put you in touch, touch with Davide, Karina.
You can send me your email, and then I forward you the invitation.
Thanks, okay, Karina. Thank you very much.
No worries.
Any other questions for Valérie and Davide? Bruno?
Yes, thank you for these two presentations. I have a question for Davide. It seems that FHIR and the Gadgetron are very similar in terms of technology and approaches. As you say, there's an increasing number of Siemens customers who are interested in using this. This is at current time, I would say, a prototype or something that is not a product. Is there any discussion internally to Siemens to make this become a product that people buy it and then become, I would say, maybe independent in using it, and maybe potentially, since there are an increasing number of people working on either image reconstruction or image processing, that this could promote certainly the interaction between Siemens and third-party companies.
Yes, I mean, I cannot comment on the detail of what is in which version, but there is a product for Siemens coming that is called OpenRecon, and you would notice it when you install the FHIR WIP, because it has some files that are called OpenRecon, which will become product. I have to check for which baseline. I would assume a VA50 or something like that, in which you can already include your reconstructions and your post-processing. Obviously, the idea is that FHIR would be more like the cutting edge of, so we add features rather in the WIP first, and then we see how they perform. We use all the call and all the customer experience to debug them. And then little by little, the functionality gets into the product. But yes, that's indeed one of the main big plans of the last couple of years within Siemens, is to have this as a product.
Okay, another potentially non-politically correct question. Are you at Siemens willing to use this Gadgetron and open source software as your reconstruction product, I would say, because at some point you can benefit from all the most advanced reconstruction tools that are provided, that are developed by the research community.
I mean, to try to answer politically correctly, I think this has already happened with post-processing tools. So if you see, for instance, Siemens, I mean, it's an MR company, so at some point could not support all the great post-processing tools that were coming up. And this Circle, for instance, is a great example of this happening. And for instance, I would say quantitative perfusion, it's a great example of a different reconstruction being given out more or less with the blessing of Siemens, which is now supported by FHIR, but you know, it has come from the community, the need of this quantitative perfusion. So I would say that this is the direction. I don't know exactly what the policy would be, because at some point you need the CE label on something. So while this could be labeled as a, so from, you know, you label a CE until you give the raw data out, and then the rest is obviously not CE labeled while the customer or the collaborator puts his or her reconstruction. At some point there will have to be a mechanism in which, in a collaborative way, we get CE label if we want to have this as a product. But I think this is one of the directions that they are taking, yes. I don't know exactly how it will work, but I would wait and see. Indeed, it's.
Thank you.
Of course.
I think the team in Lausanne wants to ask a question.
Yes, I'm sorry for my ignorance, but when I'm listening to these two talks, you know, now I cannot figure out what should I use. I mean, there are so many redundancies. So perhaps if Davide could tell me why I should use FHIR and Valerie could tell me, make a pitch for Gadgetron, that would be awesome.
But with FHIR, you can use Gadgetron. So.
But you can use Gadgetron without FHIR.
Yeah. But it's very complicated, as Valerie pointed out in his last slide.
Yes. No, I don't want to defend any specific solution. It's really up to the team. I think it will depend on the skill you can have in your team. If you have a Siemens support, maybe easier to go with Fire. If you don't have Siemens support, I think you should go to Gadgetron because it depends of the. I think it will depend of the skill you have. You need someone with at least a bit in. If you go to Gadgetron, you have to deal with the network, and the first time it's complicated. But the key message is there are many people now that can help you, at least in France. And in big center in London also, at UCL, at King's College, and at the NIH in many sites also. So if you want to test it, please go see the community.
Okay, Davide. So I think Valérie is touching a very important point, right? Because Gadgetron has a very long and amazing history of open science, community sharing, a very good website as well. Valérie is answering all the questions from all around the world every day. So how big is the Fire community? And do you guys have an open website where we can ask questions to a team of engineers and quickly expect an answer actually?
I mean, so Fire was born as Kelvin's idea and to support indeed Gadgetron, because exactly as you said, Gadgetron has a big community around it. People are developing in it, and then with every software line, it came, the problem of we need to be compatible, or we need to, somebody to take care of this, and that's how Siemens decided to go with Fire, with Kelvin's solution, because then if it's a WIP, then it's automatically maintained, and then you create a software independent platform. So once you have the WIP in your software version, then you don't have to change anything from your side, right? And the WIP is maintained by Siemens. And if you think about it, that's the same concept then will be productized, right? The product will come with the standard software. And as a user, you don't have to take care of any sort of compatibility. Whereas, for instance, if you program in ICE or whatever, or I think even in Gadgetron now, you have to take care of the different software lines. And the difference obviously is Fire as, I don't know, it's 1.5 years old or something like that. So, and it's still developing. So we're still debugging a lot of issues. There isn't a website in which we answer questions. However, there is this weekly call, which is very useful because it's hands-on, like one person shares a screen. And we look at the code together with Kelvin, which is actually the one that knows all the details of the Fire interface. And I think so this, for instance, used to be bi-weekly. It's now weekly because there are a lot of people, a lot of questions. And I think the more people use it, the more it will grow. And the only thing you need is a project that is interesting, that we can, have in our radar. Because obviously this is supported by Siemens. So it's an effort from a Siemens employee to put the time to answer questions, to debug. So it has to be some sort of project agreement between the site and Siemens. With Gadgetron, I think you are free to do whatever you want, as long as you find the expertise online that allows you that gives you the help to implement this. Siemens is saying, okay, we offer the support. Obviously, it has to be for, at the beginning, a limited number of projects until it becomes product. And B, it's a community that is growing. So, for instance, not only Kelvin now can answer questions. We have a couple of people in Lausanne that have already released. So, for Siemens, if there is an offline application that we don't want or we cannot put in ICE, we also deploy it with Fire lately. So this is a 2-level WIP. You install the Fire WIP and a second WIP that is called by Fire. So there is even internal Siemens development that is based on the Fire framework. So, I mean, I guess, yes, the difference is also the amount of time that this has been around. The Gadgetron is there since 2010, as Valérie pointed out. However, maybe you need to find the person there who knows what you want. And maybe this centralized website, it's actually very good. Valerie is giving his time, free time to answer questions, which is great for the community. And I think Siemens on its way, it's trying to support something similarly, but more, controlled, because otherwise, as a company, it would have to support all different sort of interfaces.
Thanks, David. Any other questions? No one? Maybe one quick question for you, Valerie, on Gadgetron. Personally, I really like ICE. It takes me a lot of time to implement my reconstruction, but at the end, if I want to send my reconstruction or sequence files to another center, it's just a couple of DLLs files to send, and then the sequence and reconstruction tools run quickly. What about Gadgetron? Like, if I want to send my my Gadgetron files to someone in the US and they've never used Gadgetron, and we cannot have someone like you, Valerie, in there, how easy is it to run the reconstruction, right?
Basically, the way they are doing at the NEH, they need at least someone from Siemens to install what's the ICE Gadgetron on the scanner. So it's you copy and paste the file, and you have to click on setup, basically. And then, so this is mandatory because you need to set up the connection of the functor on the Mars. And then, as a user, you have to send a Docker image. And the person, someone at the hospital has to copy the Docker image on the Mars. And you need also to give your sequence, but the sequence can be completely set up to to target the Docker image. In a way, it's more complicated than your solution. I think I agree that sharing the ICE functor is easier. I fully agree, but I think there's a limited expertise in functor as in the MRI community or at Siemens. So this was the difficulty for, but yeah, some group have the expertise. You have it, but and basically a functor is a copy and paste of a gadget. If you see the class, it's some C++. It's the same. It's really similar. But when you are a PhD student and you need to first learn the sequence, then you have to implement the ROCO, and finally, most of the time people do not have the time, most of the time, but it's not always the case, to write it in ICE. But and one cool thing, I want to say, just this thing, whatever the solution you pick, it could be Fire or Gadgetron. It's super cool to see to see the image coming back to the scanner. So I mean, you have you do your sequence, you have your reconstruction code, and it's running on your computer. But it's not the same thing when you see the image in the interface at Siemens. You're super happy. So don't hesitate to try it if you want, because another cool thing is the scanner accepts anything. So I mean, you can an image of cat to the scanner, it will be happy. It don't care. And you can send for
might create a C
sequence,
labeling problem.
You can send back, yeah, you can send back also as many image you want. So there's with the color, with the contour. In a way, the Siemens system is open. So if you have a complex reconstruction and you want to share lots of information to the clinician, like XY plot, XYZ plot, or histogram, you can also send back this kind of data to the scanner. So if you want to give metrics, the initial motivation was to compute SNR, SNR of image. Gadgetron was designed for that. They were sending back, it was for quality control. So they were sending back the SNR to the host, and you can see some graph. There's still some example on the web, and So don't hesitate to try that. It's quite fun to see.
I can only confirm that as somebody that did a PhD with ICE in this case, though seeing your stuff reconstructing at the scanner is completely different than taking the data and having it offline. It also opens completely different doors, because if you have the stuff only in your computer, you have to go and get the data, you have to go and scan your volunteers. If you have something that works at the scanner, the data just happened to you. You put it there, find a clinician that is interested, and the sequence is run by them. And if they don't get the image at the scanner, you maybe can talk to them for like 5, 6, 7 data sets, but they're not gonna run more and more something that doesn't show up, because for them it's not interesting. And maybe, Aurélien, one difference could be that if you have your own complex reconstruction or post-processing offline, if you want to put everything in ICE, you usually will have to compromise, because not all the libraries are available in a nice distribution or another. Armadillo is, for instance, my go-to example. Different Armadillo libraries are available for different ICE releases. And if you want to include your own libraries, you might have to do some extra work there. Whereas if you go with Fire or Gadgetron, which, I mean, the distribution is actually the same thing as you mentioned, Valerie, because instead of a Siemens person installing the Gadgetron functor, it's a Siemens person installing a WIP. and you still send an image, but you send it through a C2P. So the distribution of Fire and Gadgetron is probably very similar at this point. So yeah, I think compromising is, and if you prototype, like you change something in your MATLAB code, you would have to do the same change, recompile, send the DLS back. Instead, with Fire, you maybe just send another image, and they won't even note. They just copy paste a different file.
I think it's particularly true for AI, right? It would be just impossible to implement AI tools within ICE.
Within ICE, no, but I mean, we have ways to call VV5 implementation. So for instance, if you can translate your network into VV5, you can call it from ICE directly. No need of Fire.
Okay. All right. Any questions from Lausanne or from anybody else connected to the call? No, so I think it's time to then close the session. Thanks again, Valerie. Thanks again, Davide. It was so nice. Please, everyone, have a look at the chat. There is a website, Lyric Education, where you can watch all the previous Journal Club sessions. There was a couple of nice ones, actually. Thanks, everyone, for joining the session. It's great to see that we had much more people than before connected today. Just for your information, the next session is gonna be about low field versus high field CMR, but more information will be coming soon. Another very interesting topic. I wish you a nice day and a lovely weekend. Bye-bye.
Thanks, Aurélien.